Today we're going to look at exact equations, and to understand what an exact equation is, we need to understand what a differential is. From there we need to be able to test whether our differential equation is exact or not, and if it is, we'll look at a method on how to solve them. Okay, now a differential. If you have a two-variable function, f of x and y equals z, the differential is this expression. That's the partial derivative of x with respect to x dx and the partial derivative of f with respect to y dy. Now in particular, sometimes a differential equation is a differential. And in this case, our fxy is equal to a constant. Okay, now how would you know if an equation is exact or not? Well, suppose hypothetically that it is the differential of a function f. Then by the definition of a differential, when I take the partial derivative of f with respect to x, I should receive m if this is indeed the differential of f. So here I say f of sub x, that means the partial derivative of f with respect to x equals m. And likewise, the partial derivative with respect to y equals n. Okay, now so here is the test on whether it's an exact equation or not. If this is an exact equation, then when I do the second partial derivatives with the mixed partials, they should be equivalent. What I mean by that is a partial derivative with respect to x and then taking the partial derivative again with respect to y, that should be the same the partial derivative with respect to y and then again with respect to x. Okay, so if this is m and then I take the derivative again, what I need is the partial derivative of m with respect to y needs to equal the partial derivative of n with respect to x. And so that's your test. We'll look at an example to show how this works as we're going along. Now for example, we have the differential equation x cubed plus y cubed dx plus 3x y squared dy equals 0. And we're hoping this is an exact equation. If it is, that means that there is a function f whose differential looks like this. And so we need to recognize our parts. So here I have m. And here I have n. And if it's exact, I need to know, does the partial derivative of m with respect to y equal the partial derivative of n with respect to x? Okay, so to do that, let's just consider the partial derivative of m then with respect to y. So the x cubed is just a constant, that's 0, and the derivative of y cubed is 3y squared. Okay, now when I look at the partial of n with respect to x, now the y is constant, and so I'm just really considering the x. The derivative of x is 1, so I end up with 3y squared. Now if you notice, these match, so that means we have an exact equation. Now that we've verified the equation is exact, we're ready to solve it. And so the idea is, since it is an exact equation, there's some sort of function f of xy whose differential looks like our equation. So how do we find that function? If I integrate m with respect to x and y, then what I have found is, well, f. But that's not the whole story. When we integrate an indefinite integral, we have to have a constant of integration. But since m is just the partial derivative of f with respect to x, then any sort of function of y that could be added or subtracted from that would be 0. So my constant of integration is not just a plus c, but a plus gy. Now that we know we have an exact equation, we just need to solve it. So the idea is that this is the differential of some function, and I know that this fxy function, if I take its partial derivative with respect to x, I get x cubed plus y cubed. So I can integrate x cubed plus y cubed with respect to x and get my solution. So when I do that, I integrate with respect to x, I get 1/4 x to the fourth plus, it's not 1/4 y to the fourth, right? Y is a constant here. It's just x y cubed plus a constant of integration. But remember we said that since I'm integrating with respect to x, if I took the derivative, any functions of y would zero out. So actually that constant of integration needs to be some mysterious function g of y that we don't know what it is. Okay, so the next process in our solution here is to figure out what g of y is. So what I could do is take the partial derivative of f with respect to y. Now what that looks like is taking the derivative of this integration with respect to y, and then the derivative of gy, so g prime of y. This looks complicated. In practice, it's not really that complicated. Now the thing is, once I've done this, I have found the partial derivative of f with respect to y. This should equal n. So all I have to do is compare these two expressions to figure out what g prime of y is. Now, to figure out what g of y is, I will now take the partial derivative of what I just found with respect to y. So when I do that, the partial derivative of 1/4 x to the fourth is 0. Partial derivative with respect to y of x y cubed becomes 3x y squared, and then I have a g prime y. Now, since this is an exact equation, remember if I take the partial derivative of f with respect to y, I should get nxy. So nxy, remember, is this 3xy squared, so I compare it to what I found and realize here that g prime of y is actually 0. Now all I have to do to figure out what g of y is just simply integrate my g prime of y. Once I have this, I have the final piece to find my solution, as we'll see in the example. Alright, so the implication there then is that g of y equals a constant. So then my final solution is exactly the f I found, which is 1/4 x to the fourth plus xy cubed plus c1, my constant, equals a constant c. And so I can absorb that c1, and so we would really just say 1/4 x to the fourth plus xy cubed equals c. So there's an exact equation and the method of solving it. I hope this video has been useful and answered some questions. If you have further questions, leave them in the comments, and I will be glad to help.